We're trying to prove a result that ends up being equivalent more or less to Wilson's theorem. Now in this context right here, we certainly can't have p cannot be equal to 2. That's clear enough, isn't it? Because you would have to make sense out of the expression minus 1 factorial. Now this is a formulation of Wilson's theorem. You may be used to seeing -1 on this side right here, but this is equivalent right here. Now also another result that's quite useful right here, owing to the fact that, and this is, I guess you would call it trivial, some people hate saying that, but p congruent to 0 certainly implies that p minus 1 quantity squared is congruent to 1. Okay, and literally you can think of replacing p with 0 here. Okay, now we are talking mod p. I won't write that down in the name of time. But notice right here, if you move on down just a little bit here, that you see that comes in quite handy right here. The 1 that you see here is exactly this 1 right here. I can get that circled for you guys. Again, extremely useful in this context. Now what I did is multiplied both sides of Wilson's, this slightly different statement of Wilson's, by p minus 1 to get this statement right here. Okay? Now the rest of it follows very nicely just based on the definition of factorial. You can see this goes away to give you this nice result. And this is just the definition of factorial. In other words, if you pull the p minus 2 out, this is p minus 2 times p minus 3 factorial, which is equal to this line right above it. Now notice that p is congruent to 0, so it just gets replaced with -1. And we're basically done with the proof on this very next line. If you multiply through by -1, you get the answer. So we can write a QED right here. Thus we have demonstrated. Okay, again, it's multiplying through by -1 gives you the statement. Okay, so QED. Now let's just do a concrete example here. Let me come up here a little bit and see if I got some space here. Notice that if we take p equals to 7, which is a prime number of course, p equals to 7, this statement right here, p minus 3 factorial is 4 factorial, which is 24. So this would become 48 plus 1 plus 1. That's certainly equal to 49, isn't it? Equals to 49. Which is certainly congruent to 0 mod 7. Okay, folks, a concrete example to complete this thing, to convince you. Hope you enjoyed.